I have built my home automation system as an Internet of Things with nodes that are networked wirelessly and exchange messages to report sensor readings and trigger action. A node is a microcontroller like this Arduino or this ESP8266, popularly known as Node MCU, or a microprocessor like this Raspberry Pi 3. The messaging follows a pub-sub model where information is organized by topics on a messaging hub. A node can publish or subscribe to any topic and post a message as a publisher or be notified instantly as a subscriber. Within this system are surveillance cameras that monitor the environments of my home using image analysis to detect motion, using deep learning to detect presence of a person or an animal, and using the MQTT protocol, part of the Internet of Things, to send messages to the messaging hub in case of any alerts to notify us. The messaging hub hosts a website with a dashboard to display the surveillance footage. I've built this website using Node.red, a low-code technology that runs Node.js, a flavor of JavaScript, under the hood. So in this session, I will show you how to build such a website using Node.red. The panel on left has information about the day and time. The panel on the center, the central panel, has the surveillance footage with an image gallery that is updated every 30 seconds. The time interval is configurable, and the gallery will update more frequently when motion or presence is detected. The panel on right has the current weather conditions, the temperature, the wind speed, and the daily weather forecast. And this dashboard is a website displayed in the browser. And it is all built with Node.red using JavaScript under the hood. In this session, I will show you how to build such a website. So the website has two tabs: surveillance scan, which shows the footage that we are looking at as I speak, and demo, which shows tabular information, text, and images for demonstration purposes. So we will start with demo and work our way up to surveillance scan. Here is the Node.red code behind the information that is presented in the dashboard. We'll look at this next. So Node.red is a graphical programming language. We drag and drop code blocks from the panel on the left onto the coding canvas, and then string these blocks together to generate what is called a flow. A message payload, text, flows along the wire, typically from left to right. And on this journey, each block ingests the payload, does some processing on it, which may result in the payload being updated, and sends it onward to the next node. So this journey of a message payload from end to end is called a flow. And there are multiple such flows on this canvas. They can all run concurrently. The panel on the right shows some of the internals of this flow. So in the panel on the right, we can look into the payload at any stage as it flows from left to right. And the approach we will take is I will show you what a flow does. I will demonstrate behavior. And then we'll analyze the flow, working our way from the front to back. So we will go upstream and we will look at each code block and we will understand the flow in the process. So in our first flow, click on the node labeled text message. And what this does is it appends a new line to the table on this page of the website. Let's try that again. There are 2 rows to this table. And when I click on the node, the little tab sticking out the side, it injects another text message. So a 3rd row will be appended to the table, and a 4th row, and a 5th row, and so on. And the contents of each row are the same except the serial number, the row number. The contents do not change. There is a timestamp and then there is a constant message. So let us see how this node is implemented in the flow. And so working our way from back to front, the first node we will look at is this node labeled table01. And table01 is a template node for HTML. So to find this node, look in the drawer dashboard and you'll find the template node in that drawer. And what this does is it just displays the HTML that is passed to it in the message payload. So in that sense, it is a placeholder. And it has settings like the size and some other settings. The key is to pass it a message payload with the HTML, which in this case, our case is a table that we wanted to display. So where is the table coming from? Where is the message payload coming from? It is coming from the previous node. So let's work our way to the previous one. So the previous node is tabulate text. We find this node in the functions drawer. It is a special kind of function. It is also a template node. However, this is a different template than the table01 node that we just looked at. Here is where the HTML is actually fleshed out. So let's take a closer look at this node. And let's take a look at the HTML. In examining the HTML, we find HTML tags for a table with a table header. The header has 1 row with 1 cell. And that cell holds the title of the table, the name of the table, incoming. Next, we see a second row with 3 cells. And these cells have the column headers, serial number, message, and timestamp. So this is a table with 3 columns. Now, what does it contain? Looking on, we see what appears to be another row, the TR tag with 3 cells. The content of each cell is a variable. This is a special kind of variable called a mustache variable. And what this does is, this node will examine the message payload and look for a dictionary with key value pairs and the keys count, text, and timestamp to plug the values in serial number, message, and timestamp in these columns. In fact, this happens for all the dictionaries in the message payload. So we have a for loop. The for loop loops over the dictionaries in the message payload. Note that we have dropped the message tag that is typically attached to this payload, right? We say message.payload. So we've dropped that tag. So it will loop over every dictionary in the payload. And the for loop is indicated by hash at the start of the for loop and / at the end of the for loop. So what this will do, again, is for every dictionary in the payload, the dictionary has key value pairs. It will look for the keys, count, text, and timestamp, and plug those values into the cells of this row. And so we will have as many rows as dictionaries in the payload. So I think you can see now that where are these dictionaries coming from? Where is this payload coming from? From the previous node. So what happens in the previous node? We can start to uncover that now. That previous node is probably creating this payload with these dictionaries, with these keys, count, text, and timestamp, and containing the relevant information. So now let's go one step further upstream and look at the node that does that. The node upstream is this collate records for tabular display. It is a function, also from the function drawer, like the template node that we just looked at. Looking deeper. Now this is a JavaScript function. It ingests the incoming payload, which has the text message. And the order of business here is to recreate the entire table each time a new message is injected and send it on. So we need some way of creating a local historical record. Yes, a local history. By default, messages flow and are not persisted. To create local history, we use a global variable times series. So this is a local global variable. There are three types of global variables in Node-RED. This global variable is local to the node, this function node. You can also have global variables that are local to the flow and then across all the flows. Here we only need history at this node. So we use the local global variable. And it is initialized to an empty array. So when an incoming message comes in, the function calculates the serial number by adding 1 to the length of the array, that is a local history. It calculates the timestamp, the time now, using JavaScript functions. And it unpacks the text message from the incoming payload. And it packs this information into a dictionary with keys, count, text, and timestamp. This dictionary is then pushed to the array, the local history, remember? And the local global variable is updated. So it remembers this new message that just came in for the next time. And then this updated payload, this array is now passed on as the message.payload. So here is where we have prepared the information that we need to send onward to the HTML template function to render into the HTML table. So the only thing remaining is where is the text message coming from? The text message, that is the value with the key text in the dictionary. So to see that, we will go one more node upstream to the start of our flow. And so that brings us to the last node going upstream, which is the first node in our flow, which is text message. Now this is an injector node, and you can find it in the comment drawer. Let's open this node. And we've named this node text message and provided the string Shri Ram, Jai Ram, Jai Ram, Jai Jai Ram. That string is the message payload. There is also a message topic, tabula rasa, that is not used. This piece of information, the message topic, is not being used here. There is also a provision to inject the message automatically at regular time intervals if needed. We are not using that here. So now, if we take a step back and look at this flow, we inject a text message that is displayed in this table. Once the message is injected, the function collate records for tabular display creates a dictionary with the text in the message, as well as the serial number and timestamp. And the dictionary is appended to the historical record maintained at this node. The whole record is then sent to the template node, where the information is unpacked and loaded into an HTML table, which is then sent to the next node, table 01, for display, and it appears here on our website. Now, this is our basic flow, and in the subsequent flows that we will look at here in this session, we will gradually add on to this. We'll build upon this step by step until we get to the surveillance camera footage here. So in each flow, we will make a modification to this basic flow and then see the result. So far we have looked at how to show text in a table. But for surveillance footage, we are working with image data. So can we add a column to the table to show image data? Let's see how to do that next. So that is this modified flow based on the previous flow that we just looked at. And this time when I inject a message, a new row, you see a new row has appeared, and that has an image. So we can satisfy ourselves that we can work with text as well as image data. And now let's look at the flow and see how we have enabled that. The bones of this flow are the same as before, and there are some changes. As we did before, let's work our way from the last node to the first node, from the from the front to the back, and examine the differences as we go. The template table O2, let's open that. Let's take a closer look. So the difference here is I have included a style element that gives a background color of gray to the table. I use this to illustrate that the template node is a great place to include style sheets, the CSS cascaded style sheets, to style the HTML that we want to display on the website. So that's the change we have made to the template node, table O2. And as before, where is the payload that is plugged into this div tag? Where is that coming from? So let's work our way up to the previous node. So the previous node is a template node, tabulate text and image data. Let's open that. Let's expand the view. You can see we have added a fourth column to our table. The column header is snap. And a cell in this table expects an image. That is why we have this HTML image tag. And this image is expected in base64 encoded format. So base64 encoding, what is that? So that is a way of representing an image as text with no loss of information for transport over the web. So an image is encoded and then being text, it can be shipped over the web and then decoded at the point where the image is displayed to the viewer. HTML recognizes base64 encoded images. And so a base64 encoded string, a block of text, can be included in HTML as is. So that is the mustache variable, B64 image. And that is what will be displayed in a row in the fourth column. So where is this image and the other information? Count, text, timestamp. Where is that information coming from? So that is the payload of the previous message. Now let's look at that. And so our next node is the function node, collate image info for tabular display. And what is different here is, in addition to the global variable for the local history, we also have another global variable for the base64 encoded image. So time series is the global variable local to this function node for historical record. And B64 image is the global variable. Now this is a global variable at the flow level. So it is accessible to get or set, to retrieve or create or modify or delete anywhere in any flow on this canvas, in this collection. Okay. And so in making the dictionary, in addition to the serial number, the text message, the timestamp, we also include this base64 encoded image. So that is a change to the function node. Now, where is this base64 encoded image being set? Where is it coming into the picture? This is a flow.get, which is how we access the image, like context.get is how we access the time series. Where is the information being set? So this is happening in another flow where upfront, the flow has a subscriber to the MQTT broker, the topic main door, and the function save pic to flow is where an incoming base64 encoded image. So the image that is published to the broker, the MQTT broker, on the topic main door is already base64 encoded. Remember, this base64 encoding is all about transport of images over the web. So as a new image is published to the topic, that image becomes the base64 image that we referred to in the previous function. Now, all that remains is the injector node, which is identical to what we had before. So clicking on the injector node, I just clicked on that, results in a new row being added, and that row has the image. So to summarize, clicking on the injector node, the text message is injected. That text message is packed into a dictionary, which has the serial number, timestamp, and the image. That dictionary is appended to the historical record, and then that information is sent onward to the template node. The template node unpacks the information and loads it into an HTML table, and then sends it on to the template node, which applies the style sheet and then displays the table on the website. So far, we have looked at a somewhat contrived example of displaying text and image data in a table. Next, we'll look at how to handle live information coming in and how to display it in an image strip in a gallery like so. So we'll look at what further modifications are needed to our flow to enable that, starting with this simpler image strip over here. So that's coming next. So what is different about this flow? First is that the payload is injected by a node that has subscribed to the topic surveillance/main door on the MQTT broker HA hub. So let's work our way as we did before, from the front of the flow to the back. So we'll circle back to this node later. The template node main series, I'm going to expand it. Here's the CSS. I've used Flexbox layout module in cascaded style sheets to organize content better. I have fixed the image size in pixels. Typo here. And then I've used Flexbox methods to organize the images neatly in a rectangular container, which is then centered on the page, or centered inside the panel on the page. It's always a good idea to work out the arrangement and the styling using a free service like codepen.io. I have a separate video about this arrangement and styling with Flexbox. So here is the style element. Here is the style sheet and the message payload. These styles here are applied to the message payload. So where is the message payload coming from? That is the function display live footage. That is a template, display live footage. Let's look at that next. Let's open the node, the template node, display live footage. And here is the HTML template. The mustache variable uses the array stored with the key images in the payload. So we are iterating over the payload.images. We are iterating over the array that is in payload.images at the path payload.images. And as before, displaying the images in base64 encoded form. So here we have used the short form dot. Dot as a mustache variable implies every element of this array. Remember that the array begins with hash and ends with /. So this is the part that we are iterating over. And every element in that array, the shorthand for that is dot. So as every base64 encoded image is unpacked from this array, it will be shown with the image tag. So where is the payload coming from that is rendered in this template? So that is from the function node add image to gallery. So that is one step upstream of the template node that we just saw. Let's click on that. This is a JavaScript function. And it has a global variable default strip bare that is an array of base64 encoded images that is initialized to an empty array. Now, this is a global variable at the flow level, so it is accessible to all the flows in this collection that is on this canvas. And as a new payload comes in, the image is unpacked. The image is unpacked, and it is loaded onto this array. So the array is the historical record. And we are restricting the size of this array to 3. How do we do that? So we load the new image at the front of this array using unshift, and then we remove any extra images using pop. So in this way, the length of the strip is always 3. The length of the array is always 3. And so we will only be showing 3 images at a time. We can tweak this code if you want to change that later and replace 3 with a different number. So once the new image, once we have appended it to the image strip, we then prepare our payload with some additional information drawn from the incoming payload, such as the topic and the notification and information that we calculate, such as the timestamp, and then we send it on. So what we have done here is we have created the payload that will be rendered in the template, and in that payload, the 3 images, all 3 images that we want to show in the image gallery are stashed with the key images in the payload. We also update the global variable. So the new image is now part of the revised historical record, and send the payload onward. So all that is remaining now is for the payload bearing the image to come in. So let's look at that next. Which brings us to the first node in our flow, which is the subscriber to the topic surveillance/main door on the MQTT broker. I have opened that node. HA hub is the broker, surveillance/main door is a topic, and then there is other information in the settings, such as the username and the password to make an authenticated request, to make an authenticated connection, and then a subscription to the MQTT broker. So I will not open the settings because I do not want to show the username and the password. That is the information that is contained there. And it's important to remember that the messages published to the topic on the broker are serialized JSON, and they have a certain structure that is important. We can have a quick look at that structure in the debug window here. And it has a key message for the base64 encoded image. This is what a base64 encoded image looks like. It is a long string. And it has other elements like the key from, the key subject, and I think that is it. So when this payload is received, when this payload is received and then injected into this flow, it first needs to be converted into a JSON object, which is why we use the Node.js, which is also, I believe, from the function drawer. It is from the parser drawer. We use the Node.js from the parser drawer to convert the serialized JSON, which is nothing but a string, into a JSON object. And now working our way back to the front, back to the, yes, now working our way forward. So the JSON object then is sent to the function, and the contents of the payload are then unpacked and repacked into the payload that is sent to the HTML template and then sent onward for display on the website. So that is the flow that is regularly updating every 30 seconds or so and showing us an image strip with 3 images, the most recent image on the left and the previous images in the middle and on the right. Now, this is a very plain image strip. We also have other information that we would like to show, such as the timestamp, the topic, which is indicative of which node is publishing the information that we are seeing in this dashboard on the website, and other notifications like the alert. So in the next step, we will go from this plain vanilla image strip to an enhanced image gallery. And that is coming up next. So what modifications are needed to go from this plain vanilla image strip to this image gallery? We will look at that next. The difference between this flow, enhanced, LiveCam enhanced, and the flow that we looked at just previously, LiveCam, is in the styling and presentation, in the styling and arrangement of content in the presentation. So let's look at that again, working our way from the front to the back to the MQTT broker. So let's start with the template. So the style sheet has the image, which is contained in a picture frame of 3 images, which is contained in a picture frame, which has the timestamp along with the image. And picture frames are contained in an image strip. The strip has 3 picture frames. There is a header and a footer, and the header, footer, and strip are all contained in the zone. So this type of nested arrangement is very common in HTML, and it is achieved by using div tags, which are nested inside each other. And so the names here, .zone, .header, zone, header, these are the class labels for the div tags that we have used in the HTML. We've used Flexbox module layouts module in CSS to keep our content well organized, neat and tidy. And where does the content come from? Message.payload. So let's work our way up to the previous node. So the HTML template node, let me open that. We iterate over payload.images. And this time, loading the timestamp along with the base64 encoded image into a picture frame. We're also parsing out other elements of the payload, such as the alert and the timestamp for display in the header and footer. The payload that is plugged into the template is generated by the function add image to gallery. There aren't any changes there. And the node main door is the subscriber to the topic surveillance/main door on the MQTT broker HA hub. So with these changes, we now have the images flowing into the gallery that we are seeing here. There are a few other bells and whistles to these flows. When presence is detected, I send an alert to a chatbot that I have on the Telegram app on my phone. So that way I can be alerted to any presence. So in order to do this, I have added the Telegram extension to Node-RED, which makes it possible to send messages to a chatbot on Telegram. Also, I'm showing weather information for which I have subscribed to weather service. And I use the API key for that service with my current location to get temperature, wind speed, weather information and display it in the dashboard here. Temperature, wind speed, and the forecast for the day. In summary, Node-RED is a great way to ingest information flowing into the hub for home automation, for ETLing that information, and then presenting it, such as in the dashboard that I've shown here. So on my home automation hub, I have multiple containerized applications. And so in addition to Node-RED, I also have a MQTT broker, HA hub, and the Portainer dashboard to monitor all of the assets on the hub. And what I love about Node-RED is the acceleration of the development process using code blocks. And although it is described as a low-code way of building apps, it is really JavaScript, Node.js that we are using as the building blocks, with all these wonderful features like concurrency and support for parallel processing. All of these flows that you see on the canvas are programs that are running in parallel. So for a robust and scalable solution, I find this as a really great option. So it's running inside a container, which means that should I require more horsepower, can always whip up more containers to scale up this service to keep up with the more number of users. So building up from here, what is coming next is, this is the surveillance part of home automation. They also have rigged these Node MCU microprocessors to detect other events such as smoke or water flooding, or other events like a door opening unusually, other unusual activity or events inside and around the house. That information is also flowing into the messaging hub, and that is additional information that I will display here. And that is what is coming up in the next step.